So I think we're experiencing the sort of chaos of having a remote conference and an in-person conference here in Oklahoma. So we're gonna just go ahead and get started with our keynote to get things kicked off. And we're very fortunate to have Kyle Harper, who's a local here, although he hasn't been local recently. He's just come from Paris. And so we're very honored that he's taking time to speak with us today. So I think I'll just let him take over and go from there.
Great, thank you. Can I turn this around?
Sure.
Is that way I can not have to bend my neck? And do I need to use this mic for the, probably for the?
You can put it in the microphone on the webcam. So you can use both.
Is this good? Okay, good. Good morning, everybody. Nice to see you. Thank you for making this so convenient for me, coming to my hometown in Oklahoma. This really, in some ways, does feel unusually easy. First, it's the first lecture I've given in 6 months that's not in French. And talking English is just like so easy. It really is weird. Second, it's unusually convenient. I'm a native Oklahoman. I work at the University of Oklahoma. I've been on the faculty there for 17 years or so. And when I found out that the International Big History Association was having its conference in my hometown, I was really blown away. That's super exciting. Big history is an idea, a paradigm, a way of thinking that has really inspired me and my work for a number of years. I do apologize, though. I've been in Paris for 6 months. I just got back. I'm exceedingly jet lagged. And my family and I just made it back and are departing again in a few days. So I'm kind of speaking and running, which I really don't love doing, but it is what it is. I could either join for a little bit this morning or not at all. So I couldn't miss this opportunity because I'm a professional historian. And this is a very weird talk for me to give because I spend most of my life swimming against the stream, and to have a kind of room of like-minded people who are open to the integration of knowledge from physics, from biology, from the social sciences, towards a sort of unified understanding of human social evolution, of life, of the universe, is very unusual for me. I usually start by having to kind of justify why that would even be interesting. So forgive me if I argue with people who aren't even in the room. As a professional historian, I'm very used to it. As a historian, I think the big question is really maybe in a word, growth. How do human societies grow in scale and complexity in a universe that's governed by the second law? One way to think of it is that human societies are the most complex entities that we know of. I can use a little handheld device with a number of technologies, touchscreen sensing, lithium batteries, microprocessors, running amazing algorithms, GPS, the internet, to use money. All of that stuff I don't understand. In fact, I can barely even use this device. It's a miracle of technology that I can use money that I never touch. It's dirty and filthy. I haven't touched cash in a decade. Earned by teaching Roman history to students in various states of sobriety. And I can then get that money that I never touch and have somebody in the state of Oklahoma bring me fresh sushi to my door. That's an incredible network of interactions. And we should really never cease to be amazed at the order and organization and complexity that emerges in human societies and interactions. So the reason it's so amazing is that we live in a world where entropy tends to increase. I love the way that John von Neumann put it. Living organisms are very complicated aggregations of elementary parts, and by any reasonable theory of probability or thermodynamics, highly improbable that they should occur in the world at all is a miracle of the first magnitude. The only thing which removes or mitigates this miracle is that they reproduce themselves. His text, The Theory of Self-Reproducing Automata, is still an amazing and inspiring work. So think about the complexity of human societies, the complexity of our technologies. The iPhone is the product of centuries, even millennia of development in science and mathematics that then get applied by engineers to bring together technologies that probably there are very few, if any, human beings who could really fundamentally understand every single component down to its foundations in the technology that we all now take for granted, and certainly that my children cannot even fathom that people used to live without in what my children call the 1900s, like it was the 18th century or something. So I'm a historian. I want to ask, how did we get here? That's a big history question. How did a species that emerged 200,000-300,000 years ago as a fire-wielding omnivore develop into the society that we inhabit today? So here's my timeline of technological advance. And I look at it through the same lens that the great physicist Erwin Schrödinger asked, what is life? Again, 1948, still one of these foundational texts that can help us think about the world. The emergence of life itself, of increasing order, organization, complexity, in a universe dominated by the second law of thermodynamics. Sorry, it was 1944. And biologists, people interested in evolution and life, have become very interested in information as well as energy flows. And in a sense, information about the external environment is what natural selection acts on. It is that which evolves. And in a very fundamental way, increases in complexity have been driven by transitions in information storage and transmission. So what I'm going to talk about today is what I think that means for the study of human history, human social evolution, the increasing complexity of human history over time. We usually think about this in terms of energy. One of the things is, that I'm trying to do is to help us think about human social evolution, not just in terms of energy, but as a coupled system of metabolism, energy, as well as computation, information processing. I think as historians, we're relatively good at thinking about the history of energy. We know that energy is essentially necessary for human societies to reproduce themselves. In some fundamental sense, the growth and scale and complexity that's been achieved by human societies over time is a story of energy. It's a story of energy revolutions. The reason why there's 8 billion humans who consume something like 230,000 kilocalories per capita per day. These are data from Ian Morris. The reason why we're able to do that is because we've developed societies that know how to harvest energy. Chimps are incredibly intelligent social animals. They even have some technology. They have some culture, but they're fundamentally regulated by nature because they are trapped energetically. They can't go beyond the sort of energetic limits of their environment. They can eat fruit and bugs and other small monkeys, but ultimately they run out of food, and so their populations are limited. Mortality will go up or fertility will go down. Chimps never expand beyond a kind of equilibrium limit that they're held in, checked by in their natural environment. Humans are clearly very different, and it's fundamentally because we've learned to harvest energy in new ways. First as hunter-gatherers, but then, of course, as farmers, as agriculturalists who learn to harness the free energy that's captured by photosynthetic grasses that we can eat. Most of human success is dependent on the cultivation of 3 or 4 species of grass that are very good at turning sunlight into digestible seeds, wheat, corn, and rice. That's an amazing energy technology. Then, of course, over the last 200 to 250 years, human societies learned to harness the free energy that's been trapped by plants 300 million years ago in the form of underground forests, fossil fuels that have been essential in the growth of the modern world. And of course, the great challenge now is how do we get over the addiction to extremely energy-rich, energy-dense fossil fuels that are underground. But historians are pretty good at quantifying energy. This is a problem I'll come back to. It's a challenge that I think big history should take on. We're very good at quantifying energy. Everybody can sort of wrap their minds around a kilocalorie. We're much less good at quantifying the other half of the equation. So as a professional historian, I said I spend most of my time struggling against the direction of the field away from integration, unity with physics and biology. And I think it's important to understand, why is it that professional history, for one, is relatively boring. If you look at the conference program at the American Historical Association, is this being recorded? It's depressing how trivial the enterprise has become. Yeah. my colleagues are not clapping, but maybe in the room.
I can edit it.
Okay, good. Yeah, just cut these last 90 seconds. So, I think it's important really to ask intellectually, why is it that historians, professional historians, outside of people working in big history, deep history, social evolution, are relatively uninterested in ideas in biology and physics? And what are the consequences of that? For one, I think it's extremely overdetermined. There are numerous reasons why professional history is relatively detached from the interests of big history. Part of it was, of course, laid out in the mid-20th century by C.P. Snow. There's simply two cultures. Physicists and biologists are in one building. Historians, political scientists, social scientists are in a different building. And it's very hard to have the language to speak both. The language that's required to understand physics, the mathematics, very different. I went to graduate school for 6 years at Harvard University. I learned a lot of languages. In my graduate training, I did not read one paper by scientists, not one paper by someone who has a PhD in physics, biology, chemistry, zero. So it's simply the deep cultural division between the human sciences and the natural sciences. This has deep roots. My colleague Dan Smale has written really elegantly about this in the mid-19th century with the geological discovery of deep time. All of a sudden in the mid-19th century, over the course of a few decades, it became obvious that history of the universe was much deeper, much bigger than anyone had expected. And in the late 19th century, as modern universities were institutionalized, modern research universities take shape, academic enterprises are standardized, divided into departments, training is professionalized. What happens is essentially the study of history, big history, gets divided up professionally. Geologists take deep time, or I should say physicists, astrophysicists take the deepest time scales. Geologists take the deepest time scales of Earth, the last 4 billion years or so. Biologists take the history of life. So if you study primates, you go into a life science department. Anthropologists are given professionally the study of so-called primitive cultures, the origins of humanity down to the development of something called civilization or history. And Dan Smale has really beautifully shown the way in which prehistory becomes a word that is tremendously important in the way people think about the structure of time. Prehistory is one of the dumbest ideas that's ever been contrived. What in the world is prehistory? Why would you say there's something before history? He's really traced the origins of this concept to the very consequential idea that what historians do is study history, which is the time period during which documents existed. So only for the last 4,000 or 5,000 years with the development of writing, do professional historians have any role in explaining the dynamics of evolution. So this division that takes shape in the late 19th century is still extremely consequential. There is not a serious research department, a serious history department at a research university that has any specialist earlier than the ancient Near East. Think about that. It doesn't exist. Still, I can tell you the University of Oklahoma, the earliest anyone goes in the history department is ancient Mesopotamia, because that's when writing begins. So these decisions have really profound and long-lasting consequences about the way we think about the past. Of course, the idea of giving anthropologists the study of primitive cultures is a very terrible idea. It's deeply entangled with the legacies of imperialism. Of course, Europeans, whites, think of the configuration of the world in terms of civilization, which is Europeans, and primitive peoples. And anthropology is born and has a very deep relationship with this imperialist legacy in which civilized people study primitive people. In the middle of the 20th century, in the course of the 20th century, starting really with Franz Boas, there's a very healthy reaction against this that relativizes the values of civilization and simpler societies. But the reaction against the imperialist roots of anthropology also ultimately lead to a complete rejection of any idea that there is a stadial or evolutionary development of human societies. So in a very well-intentioned and necessary critique of the sort of foundations of anthropology, there's a large-scale abandonment of even the possibility of studying human history in terms of a big evolutionary framework. Over the course of late 20th century, professional history departments have a very defensive reaction against efforts to think about human societies and the history of human societies in terms that are influenced by the natural sciences, whether that's the enterprise of sociobiology, which has its limitations to be sure, or the effort to use quantitative models of human history, cliometrics, and the reaction against that is extremely strong. And it's ultimately intellectually rooted in ideas that largely come out of anthropology, literary studies, France, if we're being honest, that think of cultures in post-structuralist terms as symbolic systems, as webs of significance. I can tell you, every trained professional historian of my generation in the United States reads Clifford Geertz. You will not read any work by scientists, but you will read that culture is a web of signification that humans create themselves. So the division between the way we think about the human past and the way we think about the rest of the natural world, whether that's the physical universe or the evolution of life, is really profound, overdetermined, really strong barriers that try and block us from thinking in the same terms and using the same language. Ultimately, I think human cultures aren't just symbolic webs. They may be that, but there's something more. Human culture is an information storage device. It's something that accumulates information over time that allows human societies to solve problems in the physical universe that is under thermodynamic and various contingent physical ecological constraints that are really rooted in the chemistry of life and the contingency of evolution on Earth. Human culture is a depository of information about how to do things in that environment. So it's not simply an arbitrary web of symbolic meanings that we create. It is something that does something that acts in a universe governed by the second law. I think historians of human societies can take inspiration from directions in evolutionary biology, and particularly biologists who are interested in integrating ideas about information, computation, into the way we think about life. So the problem of biological evolution is, how do you get from a world of relatively simple life, a prokaryotic world where all that exists are single-celled organisms, to the extraordinary diversity of life that we've seen over the last maybe 100 to 200 million years or so. What happens? What is the process that gets us from the beginning of this to the end? It's evolution. And so when we think about life, the problem of explaining complexity, the process that explains it is evolution. And evolution is unthinkable apart from energy and from information. And already in the 1990s, A.R. Murray and John Maynard Smith developed a theory of major evolutionary transitions. It's been debated, it's been updated, but it's still really one of the, I think, profound ways of thinking about the history of life on Earth, the problem of evolution. How do you get from a prokaryote world to the modern complexity of life? And the answer fundamentally is a series of major evolutionary transitions. So evolution in their paradigm is a series of really breakthroughs fundamentally in information storage and processing that expand and improve the ability of organisms to harvest free energy from the external environment. So evolution really is a story about information and energy, and they list what they see as the major evolutionary transitions. People debate whether this is the right list and what are the foundations of this, but it's persuasive that fundamentally the big breakthroughs in the history of life really are all essentially developments, revolutions, major transition, discontinuous, disruptive changes in the ability of life to store, process, and transmit information. And they, I think, very rightly identify as the ultimate, the final, the most recent staggering evolutionary transition is the development of human culture. I think they're on the right track here. If you go back to their book, if you look at Murray's late articles, they never really talk about it in great detail. They sort of leave this breadcrumb there for others to develop the idea that, in a sense, the evolutionary transition represented by the emergence of Homo sapiens is fundamentally an informational revolution. That symbolic language allows human cultures to store information about the external environment in a new way. This, of course, only works because it allows organisms, it allows us ultimately to expand our ability to harvest and derive work from free energy in the external environment. I love this graph of the history of life from Olivia Judson that shows the energetic expansion that goes along with this evolution. Now, I think that there are useful ways to think about, there are useful paradigms for starting to think about the place of information in the expansion of human societies. This is an idea that I think is there, at least in some form, in a number of different frameworks. So it's not something that doesn't have some foundations already in existing ideas in the field. Cumulative cultural evolution is a body of scholarship in the field of anthropology, associated with people like Rob Boyd, Joe Henrich, who talk about the importance of the accumulation of information in human culture. Most of this work comes out of anthropology, and because of the legacy of the way the field of anthropology developed, most of the people who think in these terms tend to work on small-scale societies. They work mostly on hunter-gatherer societies, and they've done an amazing job of showing how the kinds of problems that hunter-gatherer societies are capable of solving are tremendously complex. No other species could solve the kinds of ecological problems that hunter-gatherer societies are able to solve. They have tremendous amount of information that is stored up generation over generation. No individual hunter-gatherer human in the course of a single lifetime could understand could acquire, possess the ecological knowledge of how to extract energy. What foods can I get? What foods are poisonous? How can I process certain plants to make them edible or healthy? The kinds of information that's already stored in cultures and in societies that don't have writing is really extraordinary. So human societies, even before writing, use culture as a repository for information about the external environment and how to get energy from the external environment. This is a very useful body of work. The problem is that it's never actually been seriously developed beyond the study of hunter-gatherer societies. It's right on the cusp of what I think is the most fundamental idea, which is that human cultures, even beyond the simple, relatively small-scale organization of hunter-gatherer societies, just keep gathering information about the external environment. So it's a good start, but it doesn't really get us beyond the sort of the legacy focus on hunter-gatherer societies. What about the body of work around innovation or technology? There's a really, I think, inspiring body of work around where do ideas come from. It's very good at helping us understand how human societies innovate, how they discover new information, how technologies evolve over time. But it's not very good at helping us think about what is it that accumulates? What is it that gets stored? What is it that technologies do in the external environment? And maybe most fundamentally, what are the feedbacks between increases in information and increases in metabolism, increases in the ability to harvest free energy? There is if we're being honest, a now relatively marginal, but never quite extinguished tradition of thought mostly in anthropology that does try to see the evolution of human cultures in continuity with, in intellectual continuum with biological evolution. Ian Morris he's a historian, but he's an avowed evolutionist. He had a good paper come out last year in which he tries to identify evolutionists working in the field of history. He came up with 3 or 4, of which I was one, so I was glad to be one. But it's slim pickings. The mid-20th century, this enterprise is kept alive, even as most anthropologists are reacting against evolutionary models. Leslie White struggles valiantly, I think, for a generation. It's not maybe the most complex model, culture equals energy times technology, but at least it's trying to keep the flame alive of thinking about human social complexity in continuum with biology, with life. I think one of the most promising sources for thinking about the growth of information as a central thread of human history, of the story of growth in scale and complexity, is economic history. To me, the most interesting history of the last generation has really been done by economists. Economists like Joel Mackier, who are interested in really big, deep questions about growth. The economic literature on the history of growth, to me, is one of the great resources for thinking about how is it that human societies have increased over time. It's very good in helping us think about feedbacks between population and growth, and ultimately to think about the sources of growth. Joel Mackier, if you haven't read his books, there's 4 or 5 of them that sort of approach the same question with different nuances, but Lever of Riches is a very good place to start. I think he's the best economic historian working. He really shows that the essence of modern growth, the origins of the Industrial Revolution, are intellectual. That ultimately what happens in the 17th century, which is the critical breakthrough, is that modern empirical critical science emerges. Think of Bacon, and ultimately leads to advances in mechanics. Think of Newton, that ultimately leads to technical applications. And he does a wonderful job of showing the importance of the idea of useful knowledge, and the foundation of the Royal Society in Britain, that explicitly, as part of its charter, distrusts authority. So it's empiricist. I don't care what Aristotle said. I'm going to run an experiment, and is oriented towards utility, not just what can I know about nature, but how can I use that knowledge to build a machine, is really the spark. Of course, you have to have fossil fuels. Modern growth doesn't happen without its energy, but the coal was always there, 300 million years. The coal's been there for a very long time, much longer than we've been around. Coal didn't create modern growth. The idea to use it, to harness it to do useful work, sets off the Industrial Revolution. So this is I think, a very powerful and very useful paradigm that situates the big story of human growth in terms of the growth of ideas and the expansion of information in human cultures. The reason why we live in complex societies today is because you and I don't have to reinvent the laws of mechanics, right? Any pretty bright high school junior can already start where Newton ended. It's pretty amazing, right? And that's because culture is cumulative. We don't have to reinvent everything. We store the information that previous generations have acquired. Of course, we can say plenty of critical things about economics. It uses its own sort of internal language that often is willingly ignoring the sort of physical nature and basis of productivity and of human societies. But there's a lot there to be inspired by. So in essence, what I would propose is that big history should be the story of coupled increases in information and metabolism, computation and metabolism. The acquisition of knowledge about how to do things in the physical universe as it exists under the thermodynamic constraints that are fundamental, that are stored generation after generation in human cultures. Knowledge, the capacity of individuals, groups, or societies to solve problems, the potential to solve problems in this universe. Technology really is information. Technology, economists like to think of it in terms of things like embodied capital. Embodied capital matters, obviously, but it almost it's unbelievably easy to overestimate. If America got blown up tomorrow, which apparently may happen, I didn't sleep well last night, it would take a little bit of time to build stuff back, the infrastructure, the physical capital, but you would much rather have a blueprint of all the knowledge of how to build everything than to have a physical copy of it. What matters about technology is the idea of how to do it. And this goes back even before Homo sapiens. Now, I'm sorry, I don't know this group. They call this a great deal of technological innovation throughout the last 3 million years. I think they've been studying indexes for a long time. It's relative, but this is fundamental to our nature, is the ability to develop recipes, algorithms for how to make a Handex, how to make an iPhone. Technologies are fundamentally algorithms, ideas, recipes for how to do things. And the most important thing they do is help us stay out of thermodynamic equilibrium. Human societies solve problems under the constraints that exist. We don't have enough nitrogen to grow more wheat. We can either go get guano from bird poop, which was one of the huge innovative ideas of the late 19th century, until some rather unsavory German chemists, Haber and Bosch, came up with a much more efficient way to do this. The Haber-Bosch process is a set of algorithms that you could write down more or less on a single sheet of paper that has more thermodynamic impact for human society's ability to grow than maybe any equivalent short algorithm you could write down. Oops. But it's fundamentally an idea. So are the institutional bases of our economies and societies, laws that define the way that we interact with each other. So I'm a Roman historian by training, and when we think about the evolution of human society, we should think about human society as computational agents that interact with an external environment. This is true of our society. It's true of ancient societies. When we look at Roman society, I think of it as fundamentally a series of algorithms. This is literally an algorithm from a Roman agricultural text that tells farmers how to take information from the external environment, compute an action that they will then take on the external environment that will then feed back. The Romans do this. They iterate this every day. They innovate technologically, institutionally, in their interactions, in their feedbacks with the external environment. The Roman case is the one that's closest to me. It's I think an amazing case study of the growth of complexity, but also the limits of a pre-industrial economy. They build a massive empire with huge networks for interaction, for trading, for exchange of resources. They're famous for their road building, should be equally famous for their maritime networks. They use this to create cities by pre-industrial standards, extraordinary in their size. The city of Rome reaches almost 1 million people. The urbanization rate in the Roman Empire may have been 15 to 20%, which is high for a pre-industrial society. They only innovate a little bit though. And sometimes Roman historians get offended by this, but you could write down a few new ideas that the Romans come up with. They come up with a nice recipe for concrete. They certainly come up with organizational advances, advances in law. There's modest growth. If you look at the black line is a it's the red line is a real wage index that I created years ago. There's modest growth on a per capita basis in the Roman Empire, but it's pretty limited, and it's ultimately finite. In the end, this system, this complex system, this network of human societies collapses, right? Here's Ian Morris's Human Development Index. This is the fall of the Roman Empire. It is the largest decrease in recorded history in his index. But why does the Roman Empire never transition to modern growth? The Roman Empire is this amazing entity in certain organizational ways. It's exceedingly complex. But at the end of the story, the Roman Empire doesn't go anywhere. They don't innovate very much. Most of the people are relatively poor. Life is extremely short and uncertain. And ultimately, the reason is because they're constrained by limits on energy and information. What really sets human societies free of the kind of pre-industrial Malthusian limits is the growth of information. Now, as I said at the beginning, we're very bad at thinking about this. what is information? How do you quantify information? Is information simply the number of bits that are stored? That's certainly increased. This is the number of megabytes that a human being has ever memorized in terms of text. Is this Fermi's monk? I think that's kind of arbitrary, but it makes the point. This is the number of megabytes that are stored in the world's largest library. This is the global data sphere a year or two ago. Should we think of of the information stored in human culture simply in terms of the number of bits? I actually don't think that is extremely useful, because it doesn't distinguish between the sort of arbitrary string of bits, or we can think of as syntactic information that doesn't necessarily do anything, as opposed to semantic information, information that somehow means something, information that does something in a universe. The Haber-Bosch process gets a lot of bang per bit. So like I said, you can write it down on one page. It's not a huge amount of information storage, and yet its thermodynamic impact is absolutely immense. So my colleague at the Santa Fe Institute, where I work, named David Wolpert, I should have said at the very beginning, actually everything I'm saying today is a collaboration that comes out of SFI. David, my colleague, who's a physicist and computer scientist, has this wonderful phrase that he came up with. I love this phrase, bang per bit. Not all bits are created equal. You would much rather have the 100 megabytes that you could write down the Haber-Bosch process with than billions of megabytes of cat videos that are stored on the internet, which do absolutely nothing thermodynamically, maybe emotionally. So not all information stored in human culture has the same value. I actually suspect that human hunter-gatherer societies in some ways may actually have more bits of information being processed as they operate in an ecosystem than farming. Farming is relatively simple. You harvest one species of grass. It's just that it's very valuable in harvesting the free energy via photosynthesis that we can then metabolize with our bodies for a variety of extremely contingent reasons. Farming societies probably are temporarily a simplification of human societies before ultimately surpluses and energy harvesting allow trade and the development of new levels of social complexity. Modern societies accumulate huge amounts of bits about the external environment that actually do something. Here you see just one index of that isn't a measure of the information itself, but is a measure of the ability of human societies to form essentially supercomputers that are exchanging information, that are operating as a network measured by the biggest city in the world. So we have one idea to get at this that I'll just briefly mention and would love feedback on, to think about the amount of information that is accumulated and processed in a human culture in terms of the diversity of the number of things that a human society can do. One measure of that might be an occupation. An occupation is really fundamentally information. It's embodied training. It's a series of algorithms about how to do things based on the external environment. So I'm fundamentally a professor of late Roman history. I'm fundamentally a computer that takes information about the external environment. The university will pay me if I teach that kid how the Roman Empire fell. I then make a series of information processing actions. I interact with colleagues, students. I obey certain algorithms and protocols. I read Gibbon, I read a little bit of computer science theory. And then as my output, I take an action on the environment. But fundamentally, we can maybe proxy the differentiation, the accumulation of information in a society in terms of the number of different specialized things that a society does. This isn't novel. The idea of specialization is somehow core to complexity, is a distinguished idea. Adam Smith already has this amazing insight that somehow human societies spontaneously organize themselves, and as they grow and develop, they become more and more specialized. It involves more interactions, market-based or otherwise, and it certainly has trade-offs. Paul Romer, of course, is the famous for the idea that ideas are the source of economic growth. There's a great paper by Gary Becker that argues that as human societies learn to do more things, specialization increases. So in some sense, the degree of specialization of a society, the interdependence of of specialized parts is a function of the stock of knowledge. It's a really beautiful idea that he wrote out in one paper and absolutely nobody did anything with. But if we look at the history of occupational specialization, it, at least at an intuitive level, bears this out. If you look at Roman society, it's extremely complex for a pre-industrial agricultural society. If you look at the number of occupations, there are hundreds of occupations in Roman society. It's more than what came before. It's more than what came after. It's far fewer than we have today, and it never keeps. It ultimately slows. And over the very long course of Roman history, here's time. Here's a real wage index. The Roman Empire doesn't really go anywhere because there's no breakthrough in knowledge, and there's no breakthrough in increasing specialization in the Roman world. It's very different from modern societies. This is research in progress, but if you take all of the different, simply take the words in the occupational category of US censuses over recent times, you can see the increasing complexity in the way people describe what it is that they do as an occupation. So there's really massive increases in the degree of specialization that embodies information about how to interact on the world. So this is just from US censuses. This is pretty tricky for us to extract. Let's skip through that. But if you look at data sources, like look at Wikipedia, you can see that the number of occupations increases over time, and that the degree of complexity of occupations increases over time. So it's not just that there's more pharmacists over time, but being a pharmacist becomes more complicated. This is the number of books on pharmacy written per decade, no, it's per year on a log scale over the last 200 years. So being a certain occupation also can involve more or less information over time. I think this has the potential to help us quantify, measure some important dimensions of social complexity over time. Here you see one of my favorite projects, many of you are probably familiar with, maybe even involved with, the SESHAP project developed by Peter Turchin in collaboration with others, which is a very powerful, very robust way to try and measure changes in social complexity over time. Here's sort of the big result. And you can see in these 4 different regions, their measure, this is the first principal component, sort of the basic complexity measure, increases over time. But I also be a little bit critical of it too. If you just look at like Rome, Central Italy, Latium, maximum complexity was reached about 2,000 years ago. This way of measuring social complexity is not very good at measuring increases in social complexity in modern times. I promise you, I've been to the Roman Empire, I've been to Central Italy. Italy is much more complex today than it was in the Roman world. The Roman world is relatively simple. So something is missing if we create a measure of social complexity over time that doesn't reflect absolutely massive increases in social complexity over the last 200 years, unlike anything in pre-industrial times. So this is ultimately reflective of the fact that historians have been absent from the way we think about and research changes in complexity over time. Modern times are part of history, the period of human history with documents. Anthropologists generally stay away. Historians don't think in terms of increases in complexity over time. So we're trying to develop a measure based on occupational specialization that would proxy for increases in information, semantic information about how to do things in the external environment that allow human societies to grow and scale in complexity in a world dominated by the second law of thermodynamics. That's our research agenda. I hope that it's interesting and connects with many of the themes that you'll talk about today. I've left about 15 minutes. I'm happy to take questions or to hear discussion or criticism. Thank you.
You want to?
Yeah, I can moderate.
Yeah.
Thanks. My name's Ken Baskin, and thank you for this. It's very much up the line of what I'll talk to you about that later. But I think that you're part of a trend that is coming out of what exists now. One of the big guns of metamodernism is a neurobiologist And he defines life as an information processing system that computates solutions to survival challenges. And I think that's what you're talking about. It's certainly what I'm talking about. And I wanted to thank you and just say, I think we are on to something that is very, very interesting.
Yeah, well, thank you.
Yeah, there's a book out back in 2000, Evolution in Four Dimensions, where these ladies from Israel wrote a fascinating book that influenced my own development of theology. She says we have to take a look at evolution, the four dimensions she talks about are genetic, epigenetic, behavioral changes change the way animals and stuff interact with the environment, and then symbolic. When we start to have human language, it's different from other animal communications. And she developed very powerful, and then they begin to talk about symbolic technologies. It's not only developing symbolic communications, but when you start to have things like books, libraries, library cataloging system, and internet and search engines, that's hugely powerful stuff. And so this, I think you're talking about something of incredible fertility here, that we do need to pay a lot of search engines.
I'm sorry to interrupt. For the benefit of the people on the internet, I'm going to ask you to speak to that microphone.
This one.
And I'm going to bring this around.
Okay.
to Whoever makes
Ah,
the
good.
comment, and I'm hoping that that works because nobody on the internet can hear what's just been said. I apologize.
No, not at all.
So anyway, let me ask
I love the two cultures. I think Snow's book is so good. One of the things about that image of our evolution from animals up and up and up to modern humans is that it completely misses the much deeper relationship we have to all animal species, all social species. There's a great 3-minute scientific experiment, and one of the funniest I've ever seen, showing that Capuchin monkeys have an innate sense of fairness and unfairness. Well, almost all social species do. And we share so much with them. Their behaviors can be described as following the golden rule, as caring about their neighbors, as acting the way they want to be acted on. And that's all coming from a sense of fairness. That would give us a much deeper and bigger and broader and less narcissistic picture of our own species as part of all of life and social species.
I mean,
The 3-minute scientific experiment is online. You can Google it under monkeys and fairness. Frans de Waal, who's worked on, as you know, who worked on so many books on comparative animal behavior, showing how our human behavior and so on is millions and millions of years old. He had one of his postdoc students devise an experiment to show whether fairness was an innate character, and it's absolutely convincing and hilarious.
good, better than cat videos.
Our online audience could just indicate that they can still hear Kyle's response. That would be nice.
And I see a hand raised too. At some point, we will come over.
Yes, I wonder if you can hear me.
Yes, yeah, that's great. Go ahead.
All right. No, so the question is about C-sharp graph, which was shown. No, actually, I am a participant in C-sharp project, so I have lots of criticism too about some of C-sharp results. But perhaps the results are not as stupid as one may think looking at that graph. No, the point is, up to my knowledge, up to now, C# contains data up to 1800. They do not contain data up to 2000. No, so of course, it's quite clear that modern Rome is much more complex than ancient Rome. But as regards Rome in 1800, no, the difference is not as striking. Again, in 1800, Rome was not the center of empire. Again, I myself, I'm sure that even in 1800, Rome was more complex than Rome in the beginning of Common Era. But still, no, in some respects, yes, the political complexity in some respects might be higher in 1800. But so I agree that there are still some problems with the measurement of complexity even for 18th century. But still, no, the results, no, still, C# project does not claim that modern Rome is less complex than ancient Rome. That is my remark. Mhm.
Good, thank you. I think that's fair enough. And I mean, I hope I'm clear that in discussing Seshat, I'm a fellow traveler and very, very sympathetic. But I do think that the design of the framework is ultimately very good at capturing changes in social complexity, more or less from early agricultural societies to late pre-industrial societies. And whether or not, in my view, sometimes it's a little bit ambiguous when Seshat says that it ends. But regardless, the point that I think is important is this is a great idea. It's a great effort to try and quantify social complexity. It's achieved a lot. It's rigorous. But we need a way of thinking about measuring social complexity that will capture the single greatest step changes in social complexity in human history, which are those of the last 200 years. So whether or not Seshat's not built to do that, or not trying to do that, or just not good at doing it, the end result is we still have this huge problem of how can we, using the same intellectual framework, see the dramatic increases in social complexity of the last 200 years. Because in some sense, those are actually the only ones that matter. Really, very little happens in human history until the Industrial Revolution. So if we aren't somehow measuring that dramatic change in social complexity, we're really missing something fundamental. But I don't, let me just try and make sure I'm not being unfair. You're right that Seshat isn't designed and isn't really trying to say whether modern Rome is as complex as ancient Rome. I think that's the challenge.
I would like to stress that I genuinely agree with you, and I totally with you that Seshat has a huge problem with description of growth of complexity in the last 200 years, and something should be done. So in general, I'm completely with you. Mm-hmm.
Yeah, thank you. And like I say, I'm very sympathetic. I will say any research project like this, it's that ambitious, you know, you have to make choices to be practical. What Seshat has achieved already is really important, and it's still going on. It's still growing, still developing. So I sort of say this as to anyone who may be involved or interested in listening. I think that's one of the challenges. And then two, one of the other challenges for Seshat too is that it's actually pretty agnostic about what complexity is. It sort of says, let's take these different things that experts tend to agree, and then let's measure it over a number of different proxies, where it's not committed a priori to the idea that complexity is, you know, informational in nature, and fundamentally all complexity is algorithmic, which is good and bad. One of the advantages is that it can get going on the empirical side, developing data. One of the disadvantages is the complexity is just reflected in a principal component that mixes together a lot of different variables that experts tend to agree on. So it has strengths and weaknesses. Yeah. Oh, in the back. Hold on. Yes. Oh, sorry.
So my question is about how during these times of decline, when say the Roman Empire or any other society reaches a plateau and stagnates, whether there might be an intersection with this other idea about social fairness and how that plays in, whether that might be one of the causes of stagnation. For example, in the Roman Empire, the amount of information doesn't go down. There's not really a change in energy levels. They don't run out of wheat because there's a terrible drought. I mean, there are little droughts here and reason why the Roman Empire doesn't move forward through this plateau. And maybe social fairness is really a factor, because when you don't have a perception of fairness, individuals lack motivation and they lack a reason to cooperate. So even though information is still in every individual human brain, more or less, of course, for some people it's being wasted, where they're just relegated to treacherous tasks or something. But that really, why does it break down? And it might be because of a lack of social fairness. And of course, Rome suffers a lot of that, where it's no longer living up to its ideals of democracy and a nation of markers, its big elites. So I'm just wondering what you think of that.
Yeah, I mean, I think ultimately the fact that the Roman Empire plateaus, which I think is accurate, I think it's one of the most fundamental things you can understand about it, is a characteristic that's shared with all pre-industrial societies. And it's ultimately, like very fundamentally, it's ultimately thermodynamic constraint. So there's scarcity in the world, usually energy scarcity, although you can run out of other things. You can run out of nitrogen or lithium or whatever. But the Roman Empire runs out of energy, and it runs out of energy because it also runs out of ideas, runs out of information. And what's different about modern societies is that we develop ways of, when we hit constraints, when you run out of nitrogen, we come up with new ideas to make reactive nitrogen. And so in the Roman world, what's interesting is you have a lot of things go right for them. You have this huge integrated trading basin, one of the biggest and most integrated in pre-industrial history. You have military dominance for a few hundred years. They had everything, every opportunity in the world to keep going, and they just don't. And the reason ultimately is because they don't have an engine for creating innovation or ideas. There's a really good new book by Richard Saller, Pliny's Roman Economy. It's about the Roman encyclopedist of the first century, Pliny the Elder, who's brilliant, who knows everything there is to know about the natural world in the Roman Empire, and who has unbelievably little interest in either expanding beyond, like finding ways to create new knowledge about nature or to turn that to productive uses. So the Roman innovations that happen are all almost by accident. There's no systematic science at a research university where you've got people trying to understand chemistry, people trying to engineer things with that. There's no systematic engine for growth. And what happens in the modern world is different. That's why the 17th century is so important, because you get empiricism, which says, I don't care what the received ideas are. I'm going to create new ones. I'm going to test them, and I'm going to do things with that knowledge. So the Roman plateau isn't weird. Every pre-industrial society, fair, unfair, most of them are extractive in some way. They just hit these limits. And so the Roman case is just an interesting one, because they do take complexity so far under the constraints that they're given. But all pre-industrial societies, I think, are inherently somewhat fragile, because they are so reliant on organizational advances that are often very extractive. So the Romans are very good at taking people's stuff. And ultimately that's a game of very quickly diminishing returns. You can get rich by taking people's stuff. You can't grow by taking people's stuff. Still a really fundamental fact about the world. And the Romans take a lot of people's stuff, and then you run out of people whose stuff you can take. And it's kind of one of the sources of their limits.
Well, I hate to bring this to a close because the time is too quick. You know.
I appreciate the punctuality of big historians.
But many thanks to Kyle Harper for just an excellent way of kicking off our conference. So
Thank you.
if this is what you do with time lag,
I'll go back.
Thank you all. I don't even remember what's next on our schedule, but please check the schedule, and that's what's coming up.